Welcome and study with Tanzania Institute of Education.
In this lesson, we're going to cover division of polynomials and factorisation of polynomials. We'll begin by going back to division basics, starting with a quick long division calculation to remind ourselves how the steps work. Here, we divide the number 1,865 by 14. We call 1,865 the dividend, and 14 is called the divisor. Look at the first digit in the dividend, the number 1. We cannot divide 1 by 14, so we move one place over and look at the first two digits together, which make the number 18. 14 goes into 18 one time, so we write the number 1 above the line. Then, 1 times 14 is 14, so we write this below the 18 and subtract it to get a remainder of 4. Now, bring the next digit from the dividend down to make the number 46. How many times does 14 go into 46? The answer is 3. So we write 3 at the top of the line, and 3 times 14 is 42. So we write this below the 46 and subtract it, leaving a remainder of 4. Now we can bring down the final digit from the dividend, which is 5. And how many times does 14 go into 45? The answer is 3 again. So write 3 at the top, 42 under the 45, and subtract. There are no more digits in the dividend, so we have reached the end of the long division calculation. We end up with the answer 133 with a remainder of 3. When working with numbers, we would continue the division to find a number of decimal places, but we are going to use algebraic expressions in this lesson, so we'll write it like this. We can call this answer the quotient, which is the answer to a division calculation. Divisions of polynomials work in much the same way as division with numbers. For example, this rectangle has an area represented by the polynomial x squared plus 7x minus 30, and one of the sides is x minus 3. We know that the area of a rectangle equals length times breadth, so if we divide the area of the rectangle by the known side, side 1, we'll get side 2. So side 2 equals x squared plus 7x minus 30 divided by x minus 3. To divide the quadratic trinomial by the linear binomial, write the dividend below the line and the divisor on the left. Look at the first two terms of each polynomial. What times x is equal to x squared? The answer is x, so we write x above the line. Now multiply x by x minus 3. Then subtract the expression from the whole polynomial. Subtracting the polynomial means subtracting the like terms. Remember, this is the same procedure as when working with numbers. The result is 10x. Then, bring down the next term, which is negative 30. Next, ask what times x is 10x. It is positive 10, so place this above the line too. Now multiply 10 by x minus 3 and subtract the expression. The answer is 0, and there is no remainder. We can write this as an equation like so. Now we have the length x plus 10 for the second side of the rectangle. Here's another example following the same steps. This time we're left with 13 as a remainder. Let's write this as an equation, starting with the dividend divided by the divisor. The quotient, or our answer, was x plus 6 remainder 13. The remainder of 13 has not been divided through by the divisor, x minus 2, so it's written like this in the equation. How do we write an equation for a division calculation when there is a remainder? In the calculation we did at the beginning of this lesson, 1,865 divided by 14, the answer was 133 remainder 3. To write this as an equation, we start by writing 1,865 divided by 14 is equal to 133 plus 3 divided by 14. This is because the remainder has not been divided by 14, and then rearrange this by multiplying the whole equation through by 14. The equation that results tells us that the dividend, the number we are dividing, is equal to the quotient multiplied by the divisor plus the remainder. Now let's use polynomials instead of numbers. If we divide polynomial a of x by polynomial b of x, then a of x is the dividend and b of x the divisor. The quotient, or answer, will be a polynomial q of x, and the remainder will be polynomial r of x. So we have the polynomial a of x is equal to b of x times q of x plus the remainder polynomial. Let's look at an example in which we can use this information. This box has a volume equal to the polynomial x cubed plus 2x squared minus 3x. That's the only information we're given. We know that the volume is equal to the length times the breadth times the height. If one of these expressions were equal to the side of the box, then it will divide into the polynomial without leaving a remainder. We'll start by looking at x minus 3. As you can see, if we do the long division calculation, we will find that x minus 3 is not one of the sides of the box, because the quotient, or the answer of the division calculation, has a remainder. The quotient here is x squared plus 5x plus 12, with a remainder of 36. And x minus 1? If we divide the polynomial by x minus 1, we will get an answer of x squared plus 3x with no remainder. So this means that x minus 1 is one of the sides of the box. Factorising the polynomial x cubed plus 2x squared minus 3x completely gives us 3 factors. Each of these factors is an expression that the polynomial can be divided by without leaving a remainder. These would therefore be the lengths of the sides of the box: x, x minus 1, and x plus 3. Now that we know the factors of the polynomial, we can also find the roots of the polynomial. The root of a polynomial is any value for the variable that will make the whole polynomial equal to 0. If we choose a value of x that would make any one of these factors equal to 0, then the whole cubic polynomial would be equal to 0. For the first factor, x, the value of x that makes it 0 is simply 0. For the second factor, x minus 1, the value of x that makes it 0 is 1. For the third factor, x plus 3, the value of x that makes it 0 is negative 3. This gives us 3 roots of the polynomial. 0, 1, and negative 3 are the roots of this polynomial. We found the sides of the box by finding the factors of the polynomial, those expressions that could be divided into the dividend without leaving a remainder. If we get a remainder when doing a polynomial division, we know that the divisor is not a factor of the dividend. However, it takes a long time to do a whole long division calculation each time to find whether there is a remainder. The remainder theorem is a quicker way we can use for finding out the remainder of polynomial division without doing the whole long division. For example, we found that x minus 3 is not a factor of x cubed plus 2x squared minus 3x because we did the long division calculation and got a remainder of 36. The root of the expression x minus 3 is 3 because this is the number that will make the expression equal to 0. If we took this value of 3 and substituted it for x, we know it will not make the polynomial equal to 0 because 3 is not a root of the polynomial. But what would happen instead? We would get an answer of 36, which is the same as the remainder. This leads us to the remainder theorem. In formal terms, the remainder theorem states, when a polynomial p of x is divided by a linear divisor ax plus b, then we can substitute the root of the linear factor, which has a value of minus b divided by a, into the polynomial to find the remainder. The remainder theorem leads us to the factor theorem, which gives us a way to check whether a given linear polynomial is a factor of another polynomial. That's because we know that a factor of a polynomial is an expression that can be divided into the polynomial without leaving a remainder. So if we use the remainder theorem to find the remainder, and the remainder is equal to 0, then we have found a factor. Here we have a rectangular shape, and a polynomial that represents its area. We need to check whether 2x minus 4 is a factor of the polynomial 2x squared plus 2x minus 12. In other words, could 2x minus 4 be one of the sides of the shape? If 2x minus 4 is a factor, then 4 divided by 2 would be a root of the polynomial, a number that makes the whole polynomial equal to 0. So let's substitute the number 2 into the polynomial. The answer is 0. So we can conclude that 2x minus 4 is a factor of the area polynomial. The factor theorem is stated in formal terms like this. When a polynomial p of x is divided by a linear polynomial ax plus b, then ax plus b is a factor of px. If we substitute negative b divided by a into the polynomial and get an answer of 0. Let's do an example to apply the factor theorem. Is x plus 3 a factor of these two polynomials? First, we need to find the root of the linear polynomial x plus 3, which is given by negative b divided by a. It is negative 3. In a, if we substitute negative 3 into the polynomial, we find an answer of 0. So x plus 3 is a factor of 2x plus 6. In b, if we substitute negative 3 into the polynomial, we find an answer of negative 9. So x plus 3 is not a factor of this polynomial in b. In fact, there will be a remainder of negative 9 if the polynomial is divided by x plus 3. To factorize a polynomial, you write it as the product of two or more other polynomials. Here is an example for a quadratic polynomial. Factorize 3x squared plus 3x minus 36. First, we take out a common factor of 3, and the result is x squared plus x minus 12. We can then factorize this polynomial to two factors, x minus 3 and x plus 4. So the factors of the polynomial are 3 and x minus 3 and x plus 4. For cubic polynomials, we generally have to follow a bit of a trial and error process when factorizing. Follow these steps. Find one factor, ax plus b, by trial and error. Look at the coefficients of the polynomial px and guess a possible root, minus b divided by a. You can also divide the polynomial by the leading coefficient so that you can find a single number, b, instead of minus b divided by a. Number 2. Use the factor theorem to check whether it is a root by showing that p minus b divided by a equals 0. Number 3. When you have found a root that works, divide px by the factor ax plus b to obtain a quadratic polynomial. Number 4. Apply the standard methods of factorization to determine the two factors of the quadratic polynomial. Let's look at an example. Use the factor theorem to factorize the cubic polynomial px equals x cubed plus 3x squared minus x minus 3. We need to find the first factor by trial and error. First, we try x minus 2 and substitute the root of this factor, which is 2, into p of x. The answer is 15, so it is not a factor. Then we try x minus 1 and substitute 1 into p of x. The answer is 0, so x minus 1 is a factor of p of x. Then we divide p of x by x minus 1 using long division. The result is a quadratic polynomial, x squared plus 4x plus 3. This is easy to factorize, and our final factors are x minus 1, x plus 3, and x plus 1.